And then on behalf of Selco and Trout Nutrition, I would like to start the program, beginning with a deep dive into a very important topic, a little bit more at the forefront of the aquaculture innovation. First speaker today will shed a light on elevating aquatic feed sustainability, unveiling the role of unicellular organisms. Giving a warm welcome to our first speaker. It's the head of the Center for Feed Technology at the Norwegian University of Life Sciences. And the big round of applause and a warm welcome is for Mr. Dejan Miladinovic. There he is. Now the Q&A is open. Should you have a question during the presentation of Mr. Miladinovic, please enter the question already in the system. And after his presentation, we will have an interactive part for some questions. But first, the floor is yours.
Thank you very much. Welcome to all our viewers throughout the world. And we have seen that there are so many viewers. So today, after we have heard several topics in a previous session, now, in this global session, we will talk a little bit about unicellular organisms. Unicellular organisms, you have already experienced them, you have seen them. Some of you maybe even have tasted them many times, intentionally or intentionally. But what I really want to focus and stress, and we have heard actually several times this, and I think that this is really very important information. We don't feed the animals because we like to feed the animals. We feed the animals because we like to feed ourselves. So if we'll just think that one person needs to consume at least 60 grams of protein per day, and then that about 800 million tons of protein will be required to feed people in 2050, this is more than 50% of today's production protein. That's quite a lot, you have to admit. And then if you will just look or think of beef cattle needs about 100 kilograms of feed to produce only 5 kilograms of body mass. And then if you transfer this to pure protein, this is only 1.3 kilos of pure protein. So the question really is this calculation possible to achieve if we will have only these kind of animal models? Well, I guess the answer is obvious. No, we can't with that. We have to get to sustainable aquaculture. We are in the realm of aquaculture, of course, and this is very important. We have raw materials, which I call generation 1 raw materials. Of course, these materials, they are commercially available, but the problem really is that they are in direct competition with the human food supply. And in order to make it sustainable, of course, we want to avoid using these vast resources of arable land, irrigation systems, fertilizers, and so on. And that's where the idea for a second generation ingredient came, which is less competitive with human food, and you really don't require tremendous land. Neither you need irrigation processes, neither fertilization, and this is really based on microbes, and it's based on potential, of course, several insects. So what actually do we think when we are saying we want to produce sustainable aquatic feed? So what I'm saying to my students, well, the thing is, what is feed production basically? Feed production is utilizing certain technology and machines to produce the best possible quality with the cheapest possible materials upon the agreed price. That's it. That's what we talk when we are talking about feed production, feed technology, and this entire science. We want to have increased value with lower or lowest possible costs. So when we are talking about the aquaculture sustainability, we all know, we have seen that aquaculture is really the fastest growing subset of agriculture. And there are some problems like overfishing, destruction of aquatic habitat, and inefficient feed, unfortunately, management and practices are important topic that we have to raise in order to get to this point to say that we are really sustainable in the production. When we are looking at the aquatic or aquaculture growth, aquaculture farming, we really see that wild catch seafood is very stable, whereas the aquaculture seafood is really dramatically increasing. And it's an amazing what we are seeing today, what's happening really in front of our eyes, how fast this growth is actually running, and we see that this is something how the future is going to be. There is no way back. Of course, when we are looking at the results, which are already published 4 years ago, we can't neglect these two scenarios. One is scenario 1, and the second one is scenario 2. So basically what you see in both of those scenarios, you can conclude that there is a fish meal shortage. So if there is a fish meal shortage, we are talking about actually not of sustainable production. We are talking about non-sustainable production. We have to do something about that. So in order to really do something about it, to fill up the gap and bring these solutions, at least in Norway, this is just an example in Norway. How do we think in Norway? We believe that the situation is actually very critical, basically. So in order to get to meet the demands for sustainable feed production and aquatic, of course, farming, we need novel ingredients, and we have to industrialize them. We need to scale up the processes. So even though in Norway we are really setting focus in alternatives, alternative feed ingredients, today only about 0.4% of Norwegian salmon feed is actually including novel ingredients in a diet. Well, basically, I have to admit that it has changed actually dramatically. If you just see here in 1990s, so you had fish oil, fish meal, that was it. It was so simple. For the nutritionists, life was perfect. They didn't really have so much job to do. Today is a little bit different. After 30 years, the diet have changed quite a lot. And then if you'll see that you are having quite a decrease of fish meal, improvement and increase of vegetable protein sources, also fish oil decreased, vegetable oil increased, vitamins and minerals, more or less, they're similar, they are the same. But also novel ingredients are coming, and they are really coming rapidly. Then further on, when I said we will need lots of protein in the future, well, from this report, it's obvious that we will need about 56% more fish feed produced based on current feed conversion ratios measured in a dry weight. And you have to admit, that's actually quite a lot. 56% is a lot. Well, of course, we will have this gap, which is tremendous. But also, we have an opportunity to utilize novel marine sources. We have possibility to have different mussels, shells. We have, of course, novel ingredients. All of these are the materials that can fill up the gap. When we are talking about projects and demand in regard to different animal species, we can't neglect actually what's happening in regard to shrimps. Shrimps, they would need more than 2%, average growth rate will actually be more than 2%. And then if you just see that absolute change in regard to shrimps and prawns is really growing. And this is the tendency. The line is very straight. and we see that something needs to be changed. So we are having alternative ingredients. We are having alternative raw ingredients. We have some proteins in the milk. We have proteins in soya. We have proteins in green peas. And also, we have this tremendous opportunity of unicellular organisms, which are giving us a possibility to see the potential of utilization of these specific microbes. Nonetheless, except the protein content in the microalgae, if you stress them enough, they will answer, their response will be, I'll create more energy, and then they create more lipids. Then you can just adjust the need of your, or adjust these unicellular organisms to produce what you actually need. Would you whether produce oil, or would you ever produce a protein as the main biomass, required biomass? So there are so many different ingredients. Some of them, they can be a substitute, the alternative for a fish meal. Some of them for oil, from byproducts from a fish, krill, for example. This is a hot topic, and it was a hot topic even 15, 20 years ago. Insects, there is a talk about GMO more and more. There's lots of research going on. So basically, we have to think of this entire system as a process that's supposed to actually bring you the balance in the nature, sustainable production, and also valuable ingredients for sustainable aquaculture. At our university, Norwegian University of Life Sciences, there was a research group which produced special enzyme. And this special enzyme is even patented, and this patent was further on commercialized. So what this enzyme is actually doing? You'll take forest biomass, you'll take food waste, seaweeds, and so on, and you'll place it in a bioreactor. When you're having it in a bioreactor, then you will have, from one side, you'll have a biogas, ethanol as well, but from the other side, you will have this organic side, which will be microbial growth. That would be simple sugars will come from here, and then they will get into the food for the yeast. So further on, you'll use this yeast, you'll feed the animal, you'll go to the farm, you'll feed the animal with these pellets, and then you have sludge or organic waste that you can use further on to improve for a soil management, or you can just return it back into this biomass to be re-fermented or fermented again, so that you can have circular, basically, production, and hence, hopefully, circular economy. I have to say that this works really very well in a lab scale. It works perfectly, but when you need to upscale it, then it's a little bit tricky. What we do call this, we would just say from forest to aquatic farm, or from the forest to fork. So this situation, of course, can be done with microalgae, because they are actually growing quite fast. They are multiplying once a day, yeast every 2 hours, bacteria every 20 minutes. Isn't that great? This is just perfect. And especially when you look at the Methylococcus capsulatus versus soybean meal, you just see that crude protein is higher, crude fat is higher. It has actually quite nice amino acidic profile, except some amino acids are lacking. There is a little bit more ash, and the lysine is a little bit lower. But what's really very good, and this research was done actually here in Thailand, so there was no significant difference in survival rate when we are talking about shrimps and their performance, weight gain, growth rate, feed conversion ratio in this 6 weeks trial. Amazing results. We have to admit that. When we are talking about insect meal, of course, growth of insect is high. And then when you are thinking just about this process of sustainability, about 2 kilograms of organic byproducts, or now we are calling it byproducts. You know, we have invented the new words somehow. Before we were just calling it garbage. That was just the garbage that was just thrown away somewhere. But now we have these byproducts to make 1 kilogram of insect-based protein with a really very small required space, 1 square meter of required space. Insect meal is really actually having quite nice amino acidic profile, and it has also a very nice profile of high-grade fatty acids. And we have seen that about 30% of fish meal can be successfully replaced by insect meal for a small fish diet. However, when we are talking about shrimps, some research is claiming that up to 50% could be also be replaced by insect meal. And when we are talking about insects and salmon as a fish, salmon is like shark. They just can eat whatsoever you give them. Of course, until certain moment. Sometimes you see them, because we have been recording them on camera, so we see they will take a pellet and then they will just spit it out. Then you have to ask yourself, okay, maybe they can digest it, but they don't want to get it in the stomach. So we have to do something about it. We have to improve these products. What's really very good about insects is that they can really grow on byproducts from agri-food here, from unsold products from a food and other substrates, like, for example, blue mussels and so on. So they are really not the picky eaters, basically. The Agriculture University in Uppsala in Sweden, they actually have tested the Baltic blue mussel, and they have seen that actually mussel is a really very good organic substrate where they can feed larvae, and further on you would be able to produce animal feed here or use it as an organic fertilizer. So this is the circle which actually we are aiming for. And then when we are talking about yeast, yeast is really very good. We have seen that it replicates quite fast. And about 10 milligrams of yeast annually, in the perfect conditions, of course, can produce about 150 tons of the yeast cell biomass. So when you look at that, and when you look at the research which is already published, which is claiming that yeast species level in the diets did not affect gut microbiota, and that yeast was actually fully digested through the fish system. And also when you just understand some papers that colleagues of mine from Foods of Norway research group published, the Rula yeast and the milk yeast may possibly replace up to 40% of protein from high protein fish meal. Without, of course, jeopardizing the digestibility, nutrient retention, and retention was actually even a little bit higher, I would say. Then, when you look at yeast as a raw ingredient, you can't neglect that there are all these essential amino acids which are found in the fish meal, and except methionine and cysteine, but that's something, of course, that you can manage with other ingredients. And if you compare it to both fish meal and soybean meal, then you would just say that yeast potentially could be a very good alternative. So here we see Torula yeast and milk yeast, and compared to fish meal. Överland et al. In 2013, they published this article, which is actually saying that the Candida utilis back then it was Candida utilis, now it's C. jardini, is actually quite nicely digested in the fish gut. Of course, there is some problem here in Saccharomyces, and this significant difference is telling us that something is tricky here. So those are perfect raw ingredients, they are very good, they are having very good amino acidic profile and so on, but you have to do something about that. And if you are having an amino acid composition where the baker's yeast is having a little bit more, less lysine, these essential amino acids, still that's not enough to say that something is wrong in regard to amino acid composition. So then, if you will take in consideration muscle and microbes, those are just secretive names, so that's why they are having X, Y, and Z inside of them. But some of them work perfectly well. Some of them, they don't work perfectly well. So, these results published by Tölling et al. In 2018 for a PhD thesis, is actually showing that if you have bead-mealed diet of microalgae nanochloropsis, 30% of this microalgae could be added into the fish diet, and you can improve the specific growth rate. Feed conversion ratio goes down. So this bead milling is actually just destroying the cell wall. Once you have destroyed cell wall, you are already having very nicely and accessible protein with very good amino acid profile. So technology is very important to consider when we are talking about general situation of alternatives and general situation of sustainable feed production. So when you are looking at the effect of extrusion on cell integrity for protein solubility, Agbol et al., a colleague of mine who was a part of Foods of Norway, they have produced quite nice results, which is actually showing that the protein solubility here hasn't really changed much with the extrusion process. Actually, the extrusion process has influenced lower solubility of a protein. And basically, you can just say, yes, some raw ingredients, some alternatives are good, some alternatives are perfect, some alternatives are good enough. But some alternatives who are good enough, they can be perfect if you know how to open their molecule. Some of them, if you stress them enough, they can just create so many different layers. They can have like several layers of a cell wall. And they are basically telling you a joke. Okay, you are coming to me, I have a protection, I can protect myself. Then you need to think in different way. Now you need to think about enzymes, now you have to think about technology which will bring you the best possible digestibility coefficient, which has been here published again in 2018 in regard to non-starch polysaccharides. Because you see here, maybe all men are equal, but it's not that all non-starch polysaccharides are equal. NSP, terrestrial based, they are having really very low digestibility coefficient. Whereas if you have NSPs from microalgae, basically cell walls, well, their apparent digestibility coefficient is actually a little bit higher for both, for tilapia and a catfish too. There are challenges, of course, and some of these are the economical scale-up process, cell disruption, improving the proteins and palatability issues, as for example, for bacteria, which are having really very high protein content. You just have to accept that these challenges are not only challenges in regards to nutritional quality, but also to physical quality. And of course, and you have already shared this data with us. Sustainable ingredients are very important and very challenging things for this sustainable aquaculture that we were talking about. Physical quality is also very important. And especially if we are thinking what Kai mentioned, we don't know what's happening underwater. So therefore, we have to look at what's happening with the water, in the water by employing different kind of research, which is telling us, oh, maybe if you'll add 20% yeast in a prawn or a shrimp diet, maybe that's really very good. But something is happening in regard to its water stability. It's not as stable as, for example, if you have a controlled diet without any yeast at all, or maybe if you add 2.5% yeast. So the situation is not always as we prefer to have. The situation is actually kind of nutritional aspect and the technical aspect needs to be combined in order to create a perfect Lego system that will give you possibility to utilize these ingredients. These are challenges in future directions. First of all, it's a scaling up process in order to meet the demands for commercial aquaculture. And then also optimization to ensure this competitiveness at the market and picking up these margins that this financially you want to get stronger with or to be more cost efficient and effective. Research and innovation, first of all, regarding the selection, the cultivation techniques, the feed formulation, and so on, all of this is very important. And I can't stress enough when we are talking about regulatory consideration. Whatever science is saying, sometimes politics tends to just be quiet for a while, and then when we see how the things are going, we will help you out. So politics, they must evolve to support the integration of unicellular organisms into aquafeed for sustainable and safe aquaculture. So I can conclude that the aquatic feed industry can really move towards this sustainable production by really taking in consideration and utilizing nutritional value of all these ingredients and their real potential, as well as my second conclusion, most important really would be collaboration between researchers, industry, policymakers, within the open innovation platform. Without open innovation, it will be a little bit tricky to perform and to stay in the loop. So thank you very much. This is, oops.
Thank you so much, Mr. Miladinovic. And right now, yes, let me take the presenter. All right. Couple of questions. Considering the growing needs for sustainable alternatives, could you summarize the most promising alternative protein sources? Such, maybe we can rank it in the top 3 or in the top 2. What are the most, I mean, because you elaborated on a few, of course, and probably we have to take it holistic as a whole and see it as a mix. Plant-based proteins, insect meal, single-cell proteins. I mean, what if you are just still doing the most traditional ones, fish oil, fish meal, and you want to shift right now? What should you firstly consider?
So basically what I would consider really very first, that would be an insect meal.
An insect meal.
This is I have to say, this is really my very subjective opinion.
Well, you're here, so you're allowed to give that.
Exactly.
Yes.
So basically, I'm thinking that sustainable production is really dependent on this, again, I will say ex-garbage, or today's valuable byproduct.
Used to be considered as...
Used to be a garbage, now it's a useful byproduct, or even raw ingredient.
Yes.
And insects, they are really extremely fast biological catalysts. But if I have to say something about single-cell proteins, then I would never neglect of saying that microalgae or yeasts also are valuable, very important alternatives. Somewhere, somehow, there is a problem, geographical problem, in regards to the substrate that these potential unicellular organisms are using. Let me say you will go to sub-Saharan region. In sub-Saharan region, it's very unlikely that you're going to collect lots of sugar, isn't it? Like a biomass in the Sahara. But what you do have a lot, you do have sun, you have some water. So basically, you could produce quite lots of microalgae.
All right.
So it's not really, the general picture can't be given as it's holistic, as you said, but it needs really to be addressed by the regions.
Thank you, thank you. Let's proceed. Okay, this is a remark.
It's written, it can be as low as 6%.
Yeah, but agree that aquatic animals has best FCR. Okay.
Yeah, well, basically, if this is wrong, then the scientific publication is wrong, basically.
Oh, okay.
Yeah.
In your opinion, somebody asked, which one is easy to scale up unicellular organisms or insects? What's the best one if we have to scale it up? Is that insects?
I would just say that those are insects. I have a friend, he's an insect farmer, professor at the university in Poznan, Poland. So basically, he said that his wife, who is also a professor at the university, they needed many years, almost 10 years, to understand how to have insects to procrastinate, you know, how to make babies.
Yes, yes.
And that's a challenge. But now, that's not challenge anymore. Now, this is something that is possible to do. So they can close the loop. Normally, in the nature, you think, insects are everywhere. But it's very difficult to be an insect in this world, too.
Yeah.
There are lots of challenges for them. And we have to give them a perfect condition.
Okay. Why is it, and this is the final question due to the time limitations, why is it challenging, somebody asks, to scale up production of unicellular organisms from lab to industrial scale? Is it technological limitation or / biological limitations?
I think actually it's both.
Oh.
It's a biological limitation and technological limitation too. And this is, for example, when I'm talking about biological limitation, you have to have perfect substrate for growth of unicellular organism. And I'll just give you an example. There is an automated factory which is producing certain unicellular organism, and literally 24/7, somebody from this factory is looking at the phone, and they are manipulating the process conditions so that these process conditions will be perfect and so that the growth will continue. Of course, when we are looking at the technological limitation, that exists too. And what we can really say, the improvement is tremendous. It's really going very fast. So by combining these two, we will overcome the limitations.
All right. Thank you so much so far. Thank you for all the answers. Thank you also for the presentation. You'll be back after the break. And of course, then we're going to dive into the innovation, and we will speak also a little bit more about AI. But thank you for now.
Thank you very much.